Hi everyone, welcome to my series of sessions on how to do sensor data analysis through Arduino by constructing certain simple circuits with the help of commonly available sensors in the market. In my previous sessions I've explained how to build a very simple circuit with the help of a light dependent resistor, and I told you how to understand the behavior of the light dependent resistor with the help of Arduino by grabbing the data from the sensor to the Arduino serial monitor, and from there reading the data to the Python editor. So you please go through my previous sessions as how to build the circuit and read the data from the Arduino to the Python. Okay, in this example I already have my circuit constructed with the help of a light dependent resistor and LED. I'm studying the behavior of the light dependent resistor through two output devices. One is LED and the other is Arduino, and the data is streaming, and I'm going to write the code. I already explained in my previous sessions as how to write the code to read the data from Arduino. And in this, the purpose of this present tutorial is to plot that data through different graphs. In my just before this session I've explained how to use a wonderful library in Python called matplolib to plot the data rather interactively, so that as and when the data point is read from the Arduino, Python will try to throw that into a graph device, and the data will be updating or getting updated on the graph, and the graph moves continuously from one point to the other point. And in this session we are going to make the same plot, but a bit differently. The purpose of this session is to explain how to make a normal curve. The purpose of plotting such curves is to understand whether the sensor is behaving normally or abnormally. In other words, I can also put it in a different way, like either the light falling on the resistor or the light dependent resistor, is it that normal or abnormal, or is it that data which is streaming from the sensor to the microcontroller, is it a normal distribution or anything other than normal? So in this session we are just going to concentrate on the normal distribution. A normal distribution is a bell curve. I think you need to have some certain understanding on little statistics to follow my tutorial, especially this tutorial. I'm just going to make a small graph. Like in statistics we have a beautiful distribution called normal distribution, where most of the data is centered around the mean. So this is actually the mean. So here we'll be having mean. So most of the data, whatever we observe, is just centered around the mean with some certain standard deviations. Like we can just figure it out whether the data, how much data is centered around the mean between 1 standard deviation, 2 standard deviation, or 3 standard deviations, something like that. So we can go in this way. So here this is actually an asymptotic curve, where the tails of the curve will never touch the axis. And mostly we have a common observation that 65% or 90% of the data points are covered between plus or minus 1. Okay, the left side all are minus, right side all are plus, because we start from minus to positive. So 90% of the data points, if anything going normal, for a normal distribution, 90% of the data points are covered within plus or minus 1 standard deviation, and 95% of the data is covered between plus or minus 2 standard deviations. So this is actually the 95% of the data. Approximately 99% of the data fall between plus or minus 3 standard deviations. So this is actually the limit for the 99%, something like this. So what we are going to do, Uh, we are not going to compute this statistics, I mean the mean, standard deviation, and that we'll do anyway later after some time. But in this tutorial I'm just going to I mean we have a small technique, a graphical approach, where we can study this behavior of any distribution by merely plotting a histogram, so that when we plot the histogram, if the density of the distribution, if it appears roughly normal, then we will assume that the distribution is approximately normal, something like that. So by plotting the normal curve for a certain fixed linear vector, let's take -3 to 3, so it is possible for us to determine whether it is left skewed or right skewed. If the histogram follows exactly the normal curve, then we should be in a position to say that it is a normal distribution. Otherwise, it is other than normal distribution, something like that. Okay. So I'm just thoroughly going to write the code in order to get the data from the serial monitor. My data, I mean my controller is constantly reading the data from the environment. So for that, I already explained these things in my previous import matplolib pyplot. Why do we need pyplot? Because we are going to plot the graph, I mean the data, and we are going to show that in terms of a graph as plt. This I covered in my previous and of course we can also go for the time, but I don't think we require this. Okay, now I'm going to create my serial object, serial, and the serial port here is PTS. I think it is 19. Let's see. If it is not 19, then we'll see. While let us gather. I'm not going to take each and every data point which is streaming from the Arduino. I'm just going to read only a sample of data. So instead of putting one, in my previous sessions I put one here. I kept one here, but in this session I'm just going to limit my reading to a certain number of points. So let me take some 15, or you can take some 17, or if c less than 15, which means I would like to take only 15 data points streaming from the serial monitor. Read the data into an object called dat ser read line and decode. This I explained all these things in my strip, and that convert that as float. And there is one important problem while reading this data. Actually, I'm not using any microcontroller in my experiment. In this demonstration, I'm just simulating the data from the Linux terminal, and that is not genuinely a data from the sensor. So I'm just going to scale down that data so that it exactly resembles like a sensor data. So what I do, I just divide this particular reading value to 1000th portion. I mean I just divide that value to 1000 so that my graph looks like a bit reasonable. Okay, that you'll come to know later. And just take all this data. You can just call it append. I explained all this code in my previous. So we have two lists here. One is dat. Dat is not a list actually. Df. This is list. And of course I don't have any dat. Yeah, dat is just a point. So now come out of the loop. So we got the df. Come out of the loop, print the individual points. Here it is dat. Finally print df. I'm sorry, I have to take the individual points here, not here. So individual points here, and finally come out of the loop and print the entire vector. And now from here everything goes. First let us stop here and see whether this code really works or not. So first to save this, I'm going to save as hist sense or data hist. So let's see if we can, yeah, we are able to get the data from the serial monitor, so there's no problem. And after 15 iterations we must be able to see that sample data, which is here df. Okay, so finally we should be able to print that sample data vector and quits. So after 15 iterations we should wait for the 15th iteration. Oh my god, something wrong here. I think it's keep on going on. So print that df that it is not quitting. Oh, there is a small mistake. So here we didn't tell the Python that that it should follow a loop, I mean iterations. So again, say go back. I think we have to put that C iterations, I mean the increment after df, but anyway that's not a problem. I think let's wait and see. I think this time we should be able to quit. Yes, correct. But anyway, that is not a good way of writing the program. We can rather put it after appending the data. So the data, I think somewhere here we have to put it. We have to put the increment. So now I think this is correct. So it doesn't matter wherever you put, but that is not the right way. We read the value into the DAT, and after we append that value into a data frame and we make the increment, we come out of the loop. So this is how actual discipline should go. Yeah. So now we are going to make the figure. So for that I am going to create an object called fig, and here I think we have to go for plt plot figure. So this will set up a device for figure. Now we'll go for another object where we say take it as a subplot, fig sub figure, make one. This you don't mind right now. I mean, if you don't understand this, you don't worry, we will have a detailed discussion later. It is just nothing. I'm going to overlap another graph on the existing graph device. So for that I have to make this subfigure, because I'm going to have the histogram as well as a normal curve overlapping on the histogram. So for that I think we need to, so I'm going to make another object which is a linear vector. I'm going to use this linear vector to plot the normal curve. Okay, so here I can go for np numpy. So here I will add, I think instead of time, I think time is not required, numpy as np. So np linear space, linspace, take 1 2 minus 3 to 3, take 100 points. And now ax, which is our graph object, plot x. Now here we should be very careful. So substitute all of them into a function, that is 1 by maybe should I take square root or not? Here we have to make a function that which represents a normal curve. Okay, so first let me write it, and later I'll numpy square root of 2 multiplied numpy function pi, and multiply that with numpy exponential function, exp function, minus x square. I will explain all these things, don't worry. X square by 2 to finally by 2. So that is the function that we are going to do. I'm sorry, I think I did a mistake here. Yeah, now I have to, this is uh, this is how the line width is equal to some, let us keep it 3. Okay, let's see. And later we'll now we go for the histogram, data frame, versus data frame, and bins is equal to, let's make some 5, and alpha is equal to 0.5, and normal is equal to true. So let's try now. There is nothing. We should be, the reading is happening. So after 15 iterations, I think it should be able to print that data frame and finally plots the histogram and then quits. What is the histogram? My god. I think I must be able to make plot show. So that way, because it must have, I think. So it's going on now. So let's wait and see. Come on, yes, bingo! We got the plot here now. So we successfully printed the 15 iterations. I mean, we read the data from the sensor here for 15 iterations, and after that it prints the data frame, and the same data frame got plotted in terms of a histogram. So this way we can make the plots rather more effectively and see the data visually. That makes the experiments a little interesting. Okay, I'll just try to explain you the another. If we delete this particular argument normed, so that our plot looks a bit different. I mean, this time the normal curve, the height of the normal curve scales approximately with the height of the bar. So that let's wait and see what's going to happen. So I think the normal curve is invisible this time. But anyway, so let's keep that the argument normed is equal to true. So normalize the values, which means normalize the values. I'm sorry I did not explain about this function. I think this is just the probability density function of the linear vector x. So I'm just making use of this x in order to put the normal curve on the plot. Superimposed on the bars of the histogram. So what I do actually, I just created a linear vector with the help of numpy function linspace. I took -3 to +3, just like in this, -3 to +3, and after that I made a plot of that, and which eventually makes the normal curve. And when I make the histogram by normalizing the values of data frame here, this is actually the data that which we would like to convert into the histogram. And finally the overall plot is, this histogram is measured with the normal curve, because we have made an initial condition that make this x as a subplot of figure, so that both of them acts like subplots. So this is how things going to happen. So once again, let us finally run this code and see how does that look like. So this way we can make experiments with our sensors. We can just read the data from the environment and see whether the data which is grabbed by this particular sensor is the data that which is flowing through the sensor is really normal data or abnormal data. So here actually, if we observe this plot, it is very clear that the data is not normally distributed. There is some sort of abnormal activity in the weather or environment or in other words, I can say that the light which is falling on the sensor is not exactly the normal distribution. At a regular interval of time, the light which is falling on the photo sensor, or the data which is read by the photo sensor from the environment, is not exactly distributed as a normal distribution. What simply mean that there might be some abnormal activity either in the environment or maybe in the functioning of the sensor. So this way we can just make judgments about either about the environment in which the photosensor is living in, or the behavior of the photosensor. I hope this tutorial will help you in understanding the behavior of the photosensor or the behavior of the environment. If you like my video, please press like, subscribe to my channel, keep watching for the new content. Thank you.